What if the reason you struggle with weight isn't your willpower, but your metabolism? For decades, metabolism has been blamed, praised, misunderstood, and even feared. Some claim they were born with a slow metabolism. Others insist their metabolism is damaged. Entire industries promise to boost it. But what does science actually say? To understand metabolism, we must first strip away the myths.
Welcome to SciCuriousID, where curiosity meets science.
Metabolism is not a single organ. It is not a switch. It is not something that turns on or off after the age of 30. In biological terms, metabolism refers to all chemical reactions that occur within your body to sustain life. Every heartbeat, every breath, every neural signal in your brain requires energy. That energy comes from metabolism. At the center of this discussion lies basal metabolic rate, or BMR. This represents the amount of energy your body uses at complete rest, just to keep you alive. Even if you stayed in bed all day, your body would still burn calories to maintain body temperature, circulate blood, regulate hormones, and support cellular repair. For most people, BMR accounts for roughly 60 to 75% of total daily energy expenditure. That is significant, but it is only part of the story. Total daily energy expenditure, TDEE, consists of four main components. First, BMR. Second, the thermic effect of food, which is the energy required to digest and process nutrients. Third, NEAT. This includes subconscious movements such as fidgeting, posture adjustments, and daily walking. And finally, structured exercise. Contrary to popular belief, exercise usually accounts for a smaller proportion of daily energy expenditure than most assume. For many individuals, NEAT can vary dramatically and contribute more to daily calorie burn than formal workouts. Now let us address the central myth: the slow metabolism. Scientific data from the National Institutes of Health and large metabolic chamber studies show that differences are often modest, typically within a range of 5 to 15%. The largest determinant of metabolic rate is body composition. Muscle tissue is more metabolically active than fat tissue. Therefore, individuals with more lean mass tend to have higher resting energy expenditure. Age also plays a role, but not in the dramatic way often portrayed. Research published in the American Journal of Clinical Nutrition indicates that metabolic rate remains relatively stable until around age 60, after which a gradual decline begins. The sharp metabolic crash in your 30s is largely unsupported by data. What about metabolic damage? This term is commonly used online, yet in medical science it does not exist as a formal diagnosis. What does exist, however, is adaptive thermogenesis. When individuals undergo prolonged calorie restriction, the body becomes more energy efficient. Resting metabolic rate can decrease slightly beyond what would be predicted from weight loss alone. This phenomenon was demonstrated in long-term follow-up research on participants from the Biggest Loser study, published in the journal Obesity. However, this adaptation is not permanent destruction. It is a protective mechanism shaped by evolutionary biology. The human body evolved to survive famine. When energy intake drops significantly, the body conserves. Hormones also regulate metabolism. Thyroid hormones, particularly T3 and T4, influence cellular energy production. Severe hypothyroidism can reduce metabolic rate, but such conditions are medically diagnosable and relatively uncommon. For most individuals, everyday weight fluctuations are not caused by hidden endocrine disorders. So if metabolism is not the villain, what matters most? Energy balance remains fundamental. When energy intake exceeds expenditure over time, weight increases. When expenditure exceeds intake, weight decreases. However, this equation is influenced by behavior, environment, sleep quality, stress levels, and food composition. Protein intake, for example, increases the thermic effect of food. Resistance training helps preserve or increase lean mass. Adequate sleep regulates appetite hormones such as leptin and ghrelin. These factors subtly influence the system, but none override the basic physiology of energy conservation. Perhaps the most important truth about metabolism is this: it is adaptive, not broken. It responds to lifestyle patterns. It reflects biology, not moral failure. Understanding metabolism through the lens of physiology rather than internet mythology empowers better decisions. Instead of searching for metabolic hacks, the evidence suggests focusing on sustainable habits, balanced nutrition, resistance training, adequate sleep, and consistent activity. Metabolism is not your enemy. It is your body's most fundamental survival system. But here is the question worth considering. If metabolism is more stable and predictable than we thought, why do so many people still feel that theirs is different? Let me know your perspective in the comments.
Welcome to SciCuriousID, where curiosity meets science.